Thank you very much for staying with us. So, and I would also like to thank the organizers of this conference for inviting me to speak here. So, I'm going to talk in this presentation about a topic that might represent quite a challenge for some of us who are coming from the data science profession. So, I'm going to talk about the challenge of building internal stakeholders' trust in AI-based solution. Well, to give you a flavor of the topic I will be focusing on throughout this discussion, let me show you a couple of results that were taken from the surveys of CEOs conducted by one consulting company a couple of years ago. So this survey was actually trying to get an understanding of how CEOs perceive the AI potential. So here is the specific question that was proposed to the survey participants. So the question states, how strongly do you agree or disagree that AI will have a larger impact on the world than the internet revolution? Well, and here you can see the results that range from strongly disagree to strongly agree. And we can clearly see that the majority of participants of this survey recognized a strong potential behind AI solutions. However, next, the same participants were asked to give their hints about the current degree of integration of AI initiatives in their businesses. And here the picture was actually quite different. Well, I'm not sure if all of you can read these small letters, but basically what this picture shows that the majority of the participants recognized that at a point of time, so that was the fall of 2018, there was no any AI initiatives integrated in their companies yet. And moreover, there was quite a larger fraction of the participants who recognized that they didn't even plan to implement any AI initiatives at that moment. Well, these things might have slightly changed in between. So we are talking about something that was done 1 year ago, but still these two figures illustrate kind of gap that exists between how management perceives the potential of artificial intelligence and what is the actual pace of integration of AI initiatives across businesses. Well, one may ask, what is driving this gap? What are the key barriers to releasing, to unlocking the full potential of AI and to, in order to spread the AI integration across businesses? Well, we can think about many things. So there are several barriers. Some of them have relatively simple nature, such as the lack of skilled force, or the lack of quality data. But without any doubt, trust issues raised by the artificial intelligence, AI-based solutions, they can be at the heart of this problem. Well, when we are speaking about trust barrier to adoption of AI, we can often think about it from the perspective of customers or regulatory authorities that are representing customers' interests. And indeed, as was nicely shown by previous speakers, there is a quite wide range of ethical risks arising on this side. So there can be issues rising from data privacy and fairness to the issues related to human rights and inequality. Well, as somebody coming from the industry side, I would like to bring to the table a complementary perspective, how to address trust issues related to AI. So I would like to look at this issue from the perspective of the internal stakeholders. So basically the question I'm asking here, what kind of issues, trust issues, may be related to artificial intelligence if you look at it from within the companies? Well, speaking of that, the first group of concerns that can be identified here is actually related to data management. So let me explain. We all know that AI systems are highly reliant on the massive amounts of data, and these data are gathered from multiple sources. come in many different formats. Moreover, more and more we are using the data that are already processed by the third parties. For example, in finance industry, we can use trading signals which are based on some sentiment analysis, and we can buy this data from third parties. So the point here is that the process of collecting, assembling together, processing this data can be increasingly complex. So the natural concern that may arise here is whether the data we feed into our AI-based system are actually trustworthy. Well, having trustworthy data, it's only part of the problem, actually. Another part of the problem is to make sure that we are using this data in a trustworthy way. For example, in Europe here, we are subject to the GDPR regulation, General Data Protection Regulation. And under this regulation, it's a big responsibility of each company to make sure that the usage of data is actually in line with the privacy rules. Well, another group of concern that might arise from the point of view of internal stakeholders is an increasing complexity of the algorithms and the difficulties to explain their outcomes. Indeed, think about senior management who is used to some relatively transparent, rule-based approaches, and now we are asking them to make the decisions based on some complex rule produced by the model they didn't design and that they consider as a black box. But even for people who design the solutions, that can be quite challenging to judge the quality of the outcomes. For example, to see if a model has learned a meaningful pattern. Finally, the last but not the least, there are quite substantial risks related to the unexpected system behaviors. Well, probably one of the most famous or the infamous example of such unexpected behaviors was another chatbot released by Microsoft, not the one Paul was talking about. So I'm talking about the Tay chatbot that was released in 2016 on Twitter. And basically that chatbot was designed to imitate the conversation of American teenage girl. Though the problem was that after several hours after the solution was launched online, the bot started delivering racist and sexist messages in return. And the problem was that it was apparently faced with a massive amount of offensive content from the messages of other users. And apparently, this kind of content was not anticipated at the stage of the product design. So the solution was not taught to distinguish appropriate behaviors from inappropriate. Well, to wrap up, here I would like to point out that all these concerns related to AI-based solutions actually represent a strong reputational and financial risk for the company. And very naturally, we can guess that the fear of these risks might impede the progress of adoption of AI across corporations. Well, we have identified the problem. Now the question would be, what can we do as industry professionals, for example, to alleviate this problem? So what kind of strategy one might try to put in place in order to try to build internal stakeholders' trust in AI-based solutions? Well, in the next few slides, I will try to lay out a sort of blueprint, very subjective one, that would indicate which kind of policies and good practices one might try to apply over the different phases of the product development cycle. So, in particular, I would like to address the proof of the concept phase and the production phase. Well, let us first focus on the proof of the concept phase. So the objective of this phase is to deliver a viable prototype. So basically, this is a job of a data scientist team to work on a solution that is the best under the existing constraints. And probably the first thing a data scientist will do in order to convince other people that the proposed solution is a good one is actually to convince himself or herself that it's really a good one. So this principle can be summarized as challenging the approach. So what does it mean in practice? In practice, we can run, for example, multiple competing algorithms in order to see whether they are delivering consistent results. So it's sort of sanity check. Another kind of sanity check that we can do is to compare, for example, a more complex model against a simpler model and to see whether the complexity adds value. And even better, if we have already some rule-based solutions existing in a company, we can benchmark against these existing solutions. Well, here is an example of a use case in which these practices turned out to be quite useful to convince stakeholders in the trustworthiness of the proposed solution. So in Swissquote, we have an obligation, because we are a bank, we have an obligation to report detected cases of insider trading. So insider trading means that, there are clients that are benefiting from some private, non-public information in order to realize gains. So these cases should be monitored and reported to the financial authorities of Switzerland. So in Swissquote, we had a proprietary rule-based algorithm to detect such cases. But the main problem of this algorithm was that it was delivering too many false positives. So our legal team had a surge of work to do these manual checks and going through all these false positives. So a few times ago, actually, we came up with an idea to have some alternative machine learning-based solution in place that would aim at reducing a number of these false positives, but without jeopardizing, of course, the detection of real cases of insider traders. So this was a project that was handled by our intern, and one of the big problems she faced during this project was how to convince the main stakeholders, legal officers, that the new machine learning-based solution is actually trustworthy. Well, that problem was addressed by actually running several competing unsupervised methods. And it was shown that two of them that performed the best actually also showed consistent results. So the outcomes were consistent. And at the same time, since we had already an existing rule-based solution in place, it was possible to compare the outcomes of the retained machine learning methods with the outcomes of the rule-based solution. So we did some backtests, and this backtest showed that the machine learning-based solutions were at least as good as the rule-based, but they also achieved 10 times reductions in the number of false positives. So that was an argument that helped us to convince legal team that actually it's worthwhile to have a look at this solution. Well, let me go back to my blueprint strategy to build internal stakeholders' trust. And here I would like to bring to the table a second pillar of the strategy that can be actively used on the proof of the concept phase. So here I'm talking about frequent internal communications with domain experts and project stakeholders. So actually it's very important to make sure that people understand the key assumptions behind the methodology and key limitations of this methodology. They should also understand in general lines how these algorithms are working without going into details, of course. So why it's important? On the one hand, data scientists can benefit from constructive feedback of domain experts. But on the other hand, being transparent about methodology might help to prevent the unrealistic expectations that people might have about what a system can do and what it can't do. Well, now I would like to bring to the table another pillar of the strategy which is applicable to the solutions intended for the usage by clients. So here, I'm calling it friends and family tests, but basically this is a concept borrowed from our software department. So basically when we have a prototype, we expose it to a limited circle of employees and some clients who gave their consent to participate in this experiment. And basically this is a nice way to measure if the final audience, final target audience is actually satisfied with the outcomes delivered by the system. So this also helps to improve the quality of the product. Now let me move to the production phase. Well, the key objective of the production phase is to make sure that the system is functioning as intended without major disruptions. So here, the key concerns would be the quality of the input data and the quality of the output of the system. Well, what we can do about input? Here we can think about systematic tracking of anomalies in input data that can be done either with machine learning methods or with some rule-based approaches, but something should be certainly done at this stage. But the bigger challenges comes when we need to screen the output of the models, especially if we are talking about the large-scale applications. So in this case, what can be helpful? For example, we can install some automatic filters or simply define rules that would discard poor models, though the problem remains to define what the poor model means for us. And at the same time, it can be pretty useful to have some tools that would enable to perform manual monitoring with the possibility to shut down problematic models or components. Well, again, let me bring you to one simple use case we had in Swissquote. So this is still an ongoing project, and this project was commissioned to us by our marketing department, who wanted to better know the clients, basically people who are trading on the platform. So the objective of this project was to try to identify a profile of a trader, basically which characteristics of a financial instrument a client is sensitive to. For example, think about somebody who is trading stock. So usually we can be either a fundamental trader or technical, or maybe to combine both techniques, who knows. So we try to address this problem by training multiple classifiers. Basically for each client we had a model, but the problem we faced in the end that we had to deal with thousands and thousands of models, and we had to control their quality. So these models, on top of that, were dynamically retrained, so it was like shooting on the moving target. So to address these issues, we had to put in place these two things. First of all, we are doing some automatic quality checks. Basically, for each model, which is a classifier trained on imbalanced data, we are able to compute what I call the quality metrics of a dump classifier that is applied to this imbalanced data, and we are discarding models that are showing performance metrics lower than this critical cutoff. And at the same time, we have to do a real-time monitoring. So this is done via Shiny application. Maybe some of you are familiar with this technology. So basically, this allows us to get into details of each particular model and basically even look at the trader profile learned by a model and to compare it with past trader behaviors. So this is the way basically to judge if a model really learned some minimum pattern or it was just noise and we have to discard it. Well, to finalize my blueprint strategy, I would like to mention the least but not the last pillar of it. So here I'm talking about taking constant measurements of the impact of the system and to measure client satisfactions. So this is actually quite important to make incremental improvements of the system and to make sure that things are under control. Well, at this point, I would like to summarize the key ideas of my presentation. So this talk has evolved over the idea that a lack of trust among internal stakeholders can be actually an important blocker for the active integration of AI initiatives. But there's something that we can do as industry professionals to mitigate the problem. In particular, there should be a collective effort from data scientists, data engineer, software engineer, project management in order to put in place a framework of good practices and procedure to follow over the product development cycle. Basically, having in place this framework would help to make our products better, and this will naturally raise the level of confidence among internal stakeholders. Thank you very much for your attention.